Hello friends, this is Lieutenant Dr. Yasin from Abeda Inamdar Senior College, Department of Chemistry. Today I am going to discuss about our different syllabus in chemistry. So we are going to deal with one of the better and very nice subject, that is the basics of soil chemistry. We are going to deal with the how soil chemicals and agrochemicals will be happen in future. We are going to deal in this aspect. So today we are going to start with the very first topic, that is the soil chemistry. What is soil? What do you mean by soil? The question arises in your mind. So basically, soil is nothing but the branch of soil chemistry is nothing but the branch of science which deals with the chemical composition, chemical properties, and chemical reactions of soils. Soils are heterogeneous mixtures of air, water, and inorganic and organic solids, and microorganisms as well. So today we are going to discuss about this all factors. So basically, we can discuss objectives of the soil. What are the different objectives of the soil? The properties of the colloids, properties of the soil clays, cation exchange capacity, base saturation, the soil solution, soil pH and acidity in soil, effects of different aluminium on soil acidity. So these are the various objectives of the soil. Now what you're going to deal with, you are going to deal with the what are the properties of colloids. As everybody know, what are the colloids? Colloids are the size effects reactivity. These are the very important property of the colloids. The size with water, with chemicals, and with biological components. The surface area is the second factor, which is very important. The colloids with having the size of clay which is less than the 2 micrometers and having the charge also. Now, what is the sources of charge? In your mind, the deflect of the 0.3 into 0.3 into 6 is equal to 0.54 will be the surface area of the different soil properties of the colloids. Now, sources of the charge. What are the sources of the charge? There is the permanent charge will on the clay, that is the clay is nothing but the layer silicates which is acting in minerals. Variable charges, that is the pH dependent. The soil is important in soil chemistry, very important is what? pH. Now we can see the mineral exchange ages, oxides, hydroxides of the Fe and the Al, that are the different minerals, different chemicals which involves in the soil matter, which are the having the sources of charge. What you can say is last is point, organic matter. Now you can see the what are the charges. There are the different charges. One is the permanent charge and one is the temporary charges. Now we can deal with the permanent charges. Now we can have the soil which is having in the high in primary minerals. What are the minerals? Minerals are the silica, aluminium, magnesium, and depending upon that, we are going to deal with the pH also. So these are the permanent charges. What are the next point? Next point is what? Layer silicates with the 2 silica and 1 aluminium layers. If the layers contain only silica and aluminium, there will be a different composition of the soil. There will be a charge, different permanent charge of the soil, that is the balanced, uncharged, and the stable. You can see the different diagrams in the figure that we show that the first layer will be the 2:1 ratio, will be the silica on the top on the side and silica on the top down on the side, and the middle will be L, that is the aluminium slide. Now we can see the what is the ionic substitution charges in the permanent charges. The permanent charges contain if someone silica plus 4 charge replaced by aluminium, which is having the plus 3 charge. This is all the oxidation state. We can see charges is differently vary in the soil composition. So, or some cases in the alumina, Al plus 3 replaced by magnesium 2, that creates the charges which is on the side grounds. Now we can see the with increasing the substitution, what are the increasing charges, what are the decreasing stability, that we have to study in the this permanent charges of the substitution. Now we can have the location of the charges, how we can locate the silica and aluminum. These are the basic minerals and very important minerals which affects the strength of the soil, which affect the expandability of the soil, and the potassium fixation is a very important. The figure shows you the 2:1 ratio. We can have the silica and aluminium, and then aluminium and magnesium, and silica and the aluminium. Now we can deal with the what are the permanent charges as well in the soil. Soil is having the low, if it is soil is a low insoluble silica, magnesium and primary minerals, the lower the pH and the high in aluminium. So that is the composition of the different minerals according to the charges as well. So layer silicates with the one silica and one aluminium. Now you can see the how the distribution taking place in the charges. That is the no substitution, low charges and highly stable components. Now stack the plates, the low surface area. Why it is important? That's showing in the figure, that is 1:1 ratio. Silica, aluminium is one by one. Will showing the reports. Now you can see the different silicates layers on the kaolinite is there, micasa is there, and semichites and vermiculites are there. We can see the different variable charges as well in the minerals. These are the very important properties of the soil. The ages of the clay minerals is very important. The ages of the oxide, different oxide, hydroxides are there, and Fe and aluminium is there, which expose the ages of amorphous coating. That are the substance, the nature of the soil is there. One is the amorphous, one crystalline. Now we can see the amorphous coating of the different soil, how it reacts. These are the very important. How we can raise the pH and increase in the charges is shown in the figure. How the aluminum hydroxide and aluminum oxides are replacing and they're releasing the water capacity. Now again, distribution of the charges in the figure in the table we have given you the very important, the types of the colloid and charges, and the constant variables are there. We can see the organic, vermiculite, simicide, kaolinite and geotite. These are the different charges is given in the distribution, and the percentage also is given over there. You can see the silicate clays, how it's going to be react with the calcium, magnesium and hydrogen and the potassium. These are the different enlargement of the ages of the crystal is given. Now we can have the see there is very important. There are the two surfaces are there. One is the external surface which is given by the different calcium, magnesium and the hydrogen metals, and the internal surface also which carries the ammonium and the calcium as well. So ammonium, these are the charges which reacts in the soil, and which is the this is the only composition of the soil. We can have the a good and permanent soil. And now we can say the very important question raising on the side, that how nutrients are held. Nutrients are the very important factors in the soil. Now we can see the permanent charge, pH dependent charge, and the minus meat plus. The figure is going to show you the how the soil capacity is having the different nutrients. Now we can see the after the nutrient of the soil, how we can strengthen the retention of the different soil factors. These are the, it depends upon the type of the charges, that is a positive or negative charges, the amount of charges, and the reactivity of the H2PO4. That is the very important. And you can see in the figure how the OH and then PO is reacting the oxide, and there is a there's a cluster of the charges, and the distribution of the charges over there is to maintain the strength of the reaction. Maybe can we can explain into the different cation and the anion exchanges. Now you can see the cation exchanges, that is the addition of the cation ions into the fertilizers, root ascutes, and rainfall, the decomposition. These are the different variables, and we can see the calcium having the two cations of calcium, and it reacts with the also it is having the minerals of the potassium and magnesium as well, and aluminium as well. Now we can see the different, there are the very important factors, that is a solution of the soil. How we are going to prepare the soil solution. The plants, because it is very important objective, that plants depend primarily on the what is in a solution. What is the factor of the solution, not what is an exchange of the complex of the solids. These are the very important factor which can prepare the soil solution in action. Now we can see the typical concentration, that is the 4 Da to the 6 Da readily available. Change readily, mobile, can be lost and must be replenished. This is the how you can prepare the soil solution. Next you can see the how does the nutrient uptake occur. How we can when we a very good soil, the improvement of the soil, the solubility of the soil is there, then how you can improve the nutrient in the uptake in the occur. There's a root interpretations is there, and interception is there, mass flow is there, and diffusion rate is also is there. So you can see these are the root interpretation. Everybody knows about the mass flow and this the factors, and we can skip this because we have to focus on the, we already talked about the cation exchanging capacity. This is the yes, this is the very important question. This will ask into the examination for the 5 marks. How, what is the CEC role? Is the CEC of the role? The CEC role is, this is the capacity exchange of the cation. These are the very, which is given by this molar plus kg inverse sum of the all cations, that is the hydrogen, calcium, magnesium, sodium and aluminium extras held by the soil charges on an equivalent basis, that is a per 1000 gram. It's giving the distribution, how it's going to be calculated according to the 1000 grams per soil kilogram. So these are the buffering capacity, which is having the maximum distance of a collide into attraction, and you can have the same reaction mechanism into the soil. The graph is this figure is showing the how it's going to be act, how it's going to be act by the soil solution, whatever the soil salt replaceable chemicals, what are the active acidity. These are the different what you call the figures we can show into the and act. Now you can see how do soil become acid. There are the pH. Yes, very important question. One is the how it becomes a base, how it becomes acid. So addition of hydrogen atoms, that is the H plus ion, and acid rain, root exudes, organic matter decay, ammonium based fertilizers, breakdown of the minerals and release of air. These are the very important factor to become a soil solid. So and the next one phase is what how the removal of the calcium and magnesium will taking place into the and potassium will be sent. That is the leaching process is very important, and the uptake of the crop of basic cations is very important procedure to become a soil solid. Now the how does aluminium and affect to the pH? Al, how aluminium is going to affect the Al plus 3 solids is bound to the soil, and it will, or in a solution. This is very, that is in the combination of the charges plus 3 charges, and that is figure is showing into the how is going to be act with the hydroxide HOH. Matlab means that water molecule is going to react with the aluminum, and aluminum hydroxide will be the final what you call the results. And the now you can see the how the acid soil toxicity is important factor in the soil matters. How is going to be affect to the soil? The hydrogen toxicity and the element toxicity and the manganese toxicity, these are the variables in the toxicity medium. The hydrogen toxicity, which injury to the roots, which can injure to the roots at less than 4 pH. The decrease in the uptake of the calcium and magnesium, these are the very important factor to grow the hydrogen toxicity. Now the aluminum toxicity is there, decrease in the root growth and decrease in the calcium and the potassium uptake, decrease in the microbial activity as the rhizobia, and manganese toxicity, which can be less than the pH of 5.0 with the high total magnesium. These are the acid soil toxicity. Now you can see how much percentage of the base solution is very important. So base solution is base saturation percentage is very important. 100 into the sum of the bases, that is the cation exchange capacity, is divided by cation exchange capacity. These are the some equation we can calculate the percentage of the base saturation, and it is given by the very much example of aluminum, hydrogen, calcium and magnesium as well. These are the relationship of the graphical representation of the relationship between the soil pH and the cation holding capacity, means how we can hold the cations with the soil. These are the ratio is given into the figure. Now you can see the phosphorus of the general contained of the soil, that is generally very low in a natural soils, which exceptions are also there because it is very low, and the landscape or the deposit of the water with the sediments where phosphorus is bearing the minerals are abundant in soil parent materials, where phosphorus tests of surface soils are high due to the phosphorus that has been added to the manures and the chemical fertilizers. This will react with the increase in the phosphorus, and much is tied with the organic fraction as well, and some is typed with the oxides of aluminum and Fe, and as such as relatively unavailable. These are forms of soils. We can have the acid soil, and I already talked about this. What are the different factors of the acid soil and the calcareous? This is nothing but the alkaline soil. In acid soil, there will be conditions if aluminum and Fe is phosphate, organic phosphorus, and soil solution there. And in alkaline based soil, which are having calcium phosphate, organic phosphorus, and soil solution of HPFO4. There is the combination of -2, and here it is the in the basic is the -2 is there. And next is fertilizer of the phosphorus reaction is there, and there is a given in the representing the reaction how it's going to be react. Now you can see the how the soils can be movement of the soil is very important. The low mobility is there, factors affecting the movement, that is the very much important about how it's going to be moved. It's going to move primarily by diffusion method. How it's going to diffuse, the soil is going to diffuse, and as having the low mobility. Rates are very low into this, and less than I think 1/4 of an inch is showing, and how the factors affecting, because each and every movement is going to be affected by the different factors. One is the factor is how much content of the water in the soil, and the clay content is also important, which can be connection with the water films. Then the next is what organic binding. The phyllate of the phosphorus in the manures more mobile, and the amount of the added of the phosphorus is capacity to hold the phosphorus limited materials. This is a very important movement of the soil. You can see now you can have the what are the different factors which affect on the availability. This is the last phase of the basic of the soils. How can we understand, how can we develop the growth of the soil, how we can availability, capability, and these are the different factors is also important. This is the last phase of the our slide, that is the amount of available of the phosphorus, and different soil pH is very important. Acid soil, phosphorus, and the calcareous soil, this is the main unit. The aluminum inhibits the root growth. This is a very important, and the precipitates the phosphorus in the solution. Almost it give you the precipitate whenever it act with the soil. The calcareous soil, that's a free from carbonates, and the precipitate in the phosphorus in the solution. And the properties of the soil, that is the amounts of Fe and Al oxides, hydroxides higher in solution with having the ratio of 1:1, and then clays then the 2:1 ratio. So that's it from the soil chemistry. If you have any question, you can ask in the question box, and that's it. And it's very important. Thank you so much. Take care.